able to see my screen?
It's visible.
Okay. So, embedded systems, powering the future of smart technology. So, let's see what we are going to discuss in the webinar today. Purpose. So what's the purpose of embedded systems? What basically embedded systems are, and how they are being applied in the industry, and some highlights about careers and future scope in embedded systems. I would also throw some light on basics, market trends, case studies, career paths, and few roadmaps I would share with you. And basically, this is invented to students and professionals who are interested in embedded technology. Small professional brief about myself. I'm currently co-founder and CTO at Nodetronics Technology. I basically lead the new product development in terms of electronics, IoT, and robotics. I have worked as a senior development engineer at Conver Systems until April this year, and now I'm full-time into Nodetronics Technology, where I have been, core contributor in development of underwater robotics and surface robotics platforms. Also, I do design PCBs, develop embedded networks, program FreeRTOS-based systems, many more. Also, out of my passion and interest, I also teach a lot of students and mentor a lot of students in realizing their own projects, research, and many more things. So my vision is bridging the gaps in embedded system through education and innovation, mainly through industry collaboration. What I bring is the connection with industry. So whoever approached me, basically the students whoever approached me, I try to connect them with the industry, giving them the glimpse of the technology and the level of skill set that industry expects, and try to teach them in their own way. So jumping into the topic, what are embedded systems? Embedded systems are basically a combination of hardware and software uh, designed designed to perform a specific function within a large system. Basically, when we have uh, a air conditioner or a fridge or something like that, there we have a compressor. Compressor is a mechanical system, but to control it and give you appropriate cooling, it needs a smart control to control the RPM and the pressure in the compressor. So there we apply embedded systems where we have some microcontrollers, some actuators, and some sensors, which will control the speed of the compressor, which will control the pressure of the gas, and control the cooling effect inside the refrigerator. The same goes in microwave controllers, pacemakers. Pacemakers are something like know, which generate pace for the heart in case of heart failure. A few heart failure patients are implanted with pacemakers to generate the sine wave if the heart is failing. So pacemakers do have embedded systems, smartwatches, mobile phones. Embedded systems are nowadays everywhere in the smart world right now. So why basically these embedded systems are used is because of the real-time operation, compact design, reliability, and energy efficiency. So real-time operation in the sense like when you want to perform a small task in the instant of the second, it can do it. Embedded systems with advanced programming can execute this kind of operation. Compact design nowadays, earlier the chipsets used to be having hundreds of nanometers of processing. I mean, here you see a chipset marked on the right side, right? So this chipset is nothing but it is having a lot of transistors and uh, resistor network inside. So basically, the gap between each resistor or each transistor used to be 100, 200 nanometers. But nowadays, recently I have studied that some company in India, Renesas, is going to establish a plant in India where they are going to manufacture chips with 3 nanometer process. 3 nanometers is like even smaller than our hair. The gap between each transistor is going to be less than our hair width, which is significantly reducing the size of the chipset and also increasing the energy efficiency. How is it important in our daily life? How embedded systems are playing crucial role in our daily life, in our home, health, vehicles. In home, I have given you an example of how an embedded system is controlling your fridge temperature. Similarly, in smart speakers, washing machines, thermostats, and security systems, uh, all these things, even TVs, computers, everywhere, every smart thing, every electrical thing is having an electronic system, an embedded system to control it in a smart way. So these embedded systems are the key, which are connecting a mechanical system to your smart world. I mean, let's take a small example of your smart bulb. Smart bulb is just a light on and off, but adding an embedded system which can connect to Wi-Fi, and that uh, device is going to be added on your Google account or Apple account, and through that on your mobile phone, that smart device is shown, and you can control it through your smartphone, through your Google Home or Apple Home or Amazon Alexa, something like that. A small embedded system is enabling this. And health, obviously, glucose monitor, pacemaker. Modern day electrical tools are mostly electronic. The modern day medical tools are mostly electrical and electronic based. So, like, let's say ventilators, defibrillators, glucose monitors, many laboratory equipment used for detecting, a lot of harmful diseases are basically built out of embedded systems. Embedded systems have been, a reliable option nowadays. Earlier, chemical tests used to be performed, but right now the sensors and research has gone in such an advanced way that the chemical tests are being now replaced with embedded system based thing. Earlier, the best example of such scenario is glucose monitor. Glucose monitor has become such compact that in 1,000 rupees you are getting a sugar glucose monitoring devices in your medical shop. Earlier, if you want to check the instant glucose, you have to go to the laboratory, give you a sample post fasting and post lunch, and then wait for 2 3 hours or sometimes half a day to get the report. But right now, it's not the case. Everybody are using instant glucose monitors. It's just very small and even smaller than your mobile phone, and you just puncture your finger, get a blood drop, and put it inside it. You get the glucose levels instantly. So embedded systems has enabled that uh, convenience to its customers. In vehicles, anti-lock braking systems, engine controlling units, navigation systems, many more things. Earlier, 10, 20 years earlier, most of the vehicles used to be purely mechanical. Slowly, electrical aspects have come, and now from past 10 to 5 years, most of the things, even the commercial affordable vehicles, are loaded with plenty of electronics. A good example is anti-lock braking systems. Anti-lock braking systems are nowadays mandatory in all the vehicles from BS6 regime. So this anti-lock braking system, I guess many of you know. If someone don't know, I'll just explain a bit about it. Like this anti-lock braking system will ensure that your wheels are not locked in case of emergency braking. Emergency braking in the sense, if you see something all of a sudden and if you apply the brakes full, basically the wheels lock and you skid and you fall. To avoid that, anti-lock braking system uses wheel encoders to understand the rotation of the wheel. If the wheel is locking, they release the brakes dynamically, let that slowly roll, and then again, like it's a closed loop control basically. So like it will not let the wheel lock by itself. If there is a situation where the wheel is getting locked, the brakes are released and managed. The brake pressure is managed, and the uh, the system ensures that the wheel is not locked, and at the same time, the vehicle is also stopping. And engine control units. Now, earlier, basically, the engine control was, the amount of fuel going in, the spark timing, and everything was controlled mechanically. But somehow now, engine control units are taking that lead. The amount of fuel going in, the concept of carburetors is gone now. Everywhere, even in bikes, you see fuel injection. This fuel injection is managed by this engine control unit. It calculates how much, based on your throttle, the user throttle, it calculates the amount of fuel and air that has to combine and go into the engine. This is controlled by the engine control unit, and many other subroutines of the engine are now offloaded to the embedded systems, navigation systems, Google Maps integrated onto your dashboard, infotainment systems, not to mention that. And if you take Tesla, Tesla autopilot. It can run all on its own, even if the driver can relax, chill a bit. Though it's not fully autopilot, but the driver can relax during a long drive. And there were situations where Tesla has prevented a lot of accidents. If even if the driver is fully alert, those accidents would not have been avoided. But embedded systems has let such conditions pass with ease. So let's in detail discuss about components of embedded systems. The embedded systems do have three basic parts. One is hardware, software, and then communication. So hardwares are like microcontrollers, sensors, and actuators. Then communication is these are called communication protocols. Basically, communication protocols enable the hardware components to communicate with each other. And
I think so. You're on hold.
yeah, sorry,
Yeah, it's fine.
small network glitch, I guess. So this communication protocols enable users or the developers to communicate between microcontrollers, sensors, and actuators, exchange information, send control signals, and develop that system. And the software basically is embedded C or C++ language. They are used in building the firmwares to basically the firmware will contain information how the microcontroller has to interact between the sensors and actuators to develop this control system. In software, some latest advancements like real-time operating systems, which are like not latest, but it's advanced. It's not basic. Real-time operating systems enable the developer to access multiple sensors and actuators at the same time. So basically, microcontrollers are run one line at a time. I mean, like they go in a straight line. They cannot run multiple processes. So in that scenario, if you want to access two or three sensors on a single system, this microcontrollers cannot access this multiple sensors on a single system. So basically, the real-time when write your firmware based on this real-time operating systems, this will enable the microcontroller to access and control multiple sensors and actuators at the same instant. So basically, these real-time operating systems are extensively used in engine control units of the automobile industry and medical devices and all. In many places, this approach is being now implemented. So basically, give a small glimpse about communication protocols, I2C, SPI, UART, CAN. These are like few to break down. They are like the languages that these devices can speak. I2C has a purpose, SPI has a purpose, UART has a different purpose, CAN has a different purpose. In automobile industry, basically this CAN is extensively used. CAN is called controller area network. Controller area network has high resistance to external noises. So basically, in case of vibrations or external interferences, then that basically other motors or something generate, CAN has high resistance to that. So basically, CAN is used in automobile industry. UART and SPI are the other three are serial-based communication. I2C is very high speed, reliable in terms of short distance communication. Maximum you can communicate with under 50 centimeters. When your microcontroller and sensor are within a distance of 50 centimeters, you can use I2C. Beyond that, I2C cannot handle the speed, and there can be a lot of interferences coming in. And in terms of SPI and UART, their SPI is like not so long range, but it has a very high speed and a unique thing called master slave feature. So when you have multiple sensors and but you only want to communicate with one or two sensors, then you can use SPI communication. UART is for long range and multiple sources, multiple destinations. If you are having in your network, you can use UART. So can you talk about like the core technologies in embedded system? One crucial thing is programming languages. Programming languages like C, C++, Python are used for prototyping and the development of industry-grade embedded applications. So if you are proficient in C language, C++, Python, you are good to go for embedded programming. So as the name suggests, they're just programming languages. So the way you apply it depends on the application. So if you want to write some code which will which is necessary for some deep learning or machine learning or a website development, you can do it in Python and C++ as well. But the same language can be also used for developing embedded applications. You can program microcontrollers nowadays with C language, C++, and Python as well. Earlier, embedded applications were developed using high-level assembly languages and instruction sets, which were a lot complicated. But now, with advancement in technology, technology has enabled the developers to use C, C++, Python, and many Rust, for that matter, for developing embedded applications. So, core technologies, protocols. So protocols are also very much important because like not everyone can specialize in all kinds of protocols. I personally have a very good experience in SPI and I2C. I've been working from almost 4 to 5 years now in this field. I have a very extensive experience with SPI and I2C. Similarly, not everyone can gain the 100% expertise in all the existing protocols. I know how UART works, CAN works, I know how to implement it. But when it comes to critical applications like defense or some applications where reliability matters, expertise is needed in particular communication system. I have been hired in some projects just to handle these two communications, where rest of the team was handling UART. One guy was there in particular to handle UART communication. One guy to handle CAN. It was a project for ISRO. And even the programming languages. A guy cannot master all the programming languages. One programming language can be one guy can master one programming language and manage all the others. And like tools. Tools like IDEs. IDEs are integrated development environments. So these integrated development environments enable us like it's like VS Code if you are familiar with VS Code or your PyCharm or something like that. PyCharm is used for Python development. VS Code is used for multi-language development. Similar tools are there. Similarly, in the field of industrial embedded systems, we use Kyle or MPLabX. Kyle is platform independent. Many platforms accept Kyle as an IDE. MPLabX is limited to few manufacturers. And similarly, using VS Code also you can develop embedded application. In VS Code, there is an extension called Platform IO. Over Platform IO, you can develop C++ and Python-based embedded applications and embedded firmware. It has a diverse range of libraries and many other things. And debugging tools, basically debugging tools like JTAG or software debugging is used to debug your firmware during your testing things. Uh, and simulation tools like Proteus. Proteus is a simulation tool used to simulate your circuitry and firmware before going simulating it on your hardware. Before implementing on your hardware, sorry, you will generally recreate the circuit in Proteus, and there you can program your circuit in real time and then see how it's reacting. How you can also have it. You have a digital oscilloscope inside the software itself, and then you can see how the waveforms are being generated, how much the voltage is coming on your circuit, all digitally. So basically, Proteus is a simple. It's not simple; it's advanced simulation software. Similarly, we have many entry-level simulation softwares as well, like Tinkercad. Tinkercad, there you can simulate your ESP32 and Arduino-based sensor networks. So these are a few core technologies that are basically used in development of embedded systems. So how embedded systems and general computer systems are different. Basically, many people think both are similar. Many people nowadays think that my fridge has a computer inside, or my AC has a computer inside. It might be very good to talk like that in layman terms, but if you're an engineering graduate or an engineering professional, uh, you have to understand how they are generally different from our traditional computers and laptops. So basically, the general purpose computers have something called microprocessors. And this microprocessors can handle multiple tasks, and they do have powerful processing capacity, high memory, and flexible applications can be developed over our general purpose computers. They can be used for programming. They can be used for media generation, media editing, games development, or regular browsing stuff, which most of us do. So, but embedded systems are different. Basically, embedded systems use something called microcontrollers mostly. There are microprocessors that are being used in embedded systems as well, high-level embedded systems. But mostly microcontrollers are used in embedded systems because microcontrollers are more reliable than microprocessors. Since microprocessors can handle multiple tasks and have high resources, they might stumble. That's why we see our laptops stumble sometimes. All of a sudden, if you have 100 Chrome tabs open, it might stumble. It might uh, freeze for some time. But embedded systems, there is no scope for that. I mean, an embedded system cannot freeze itself. So they use something called microcontrollers. Microcontrollers, I have explained earlier how they work. They follow a single line. They don't, they cannot run multiple lines on at the same instant. So that's how they never fail generally. So basically, embedded systems. When an embedded system is designed, let's say embedded system of your washing machine. This embedded system for your washing machine is particular to that particular model of the washing machine. It cannot be used for another washing machine or your fridge or your TV or anything else. That system is developed only in particular to that washing machine. Even from even though it's from the same brand, another model cannot be run using the same system. It has limited resources. Let's say that your washing machine needs some RAM, some ROM. RAM is random access memory, and ROM stands for read-only memory. The memory which is exactly needed for that particular washing machine to run is only assigned on that system. No excess, no less is assigned, just to save space and save resources there. Exactly what resources are needed, they are only given, and they offer real-time performance. Real-time performance in the sense like basically in uh, systems we often see a lag. If a sensor recepts something at an instant of 10 seconds, to get it reflected on an actuator, there might be some delay of 2 to 3 seconds. It's just a small layman example. Uh, so you can find this delay. So as I told you about real-time operating systems, by implementing that programming technique, you can get real-time performance. The moment the sensor detects some change, the actuator can be immediately activated. That is something. And energy efficiency, obviously, since it has a single-purpose design and limited resources and highly optimized firmware to its application, it is highly energy efficient. It uses only what it needs. But when compared to general computers, even though your computer is not doing anything, it's idle, it consumes the same amount of battery. If you're compare, if you generally use 4 or 5 tabs of Chrome for 1 hour, it consumes the same amount of power, even though if it is idle. So it's not that optimized and that power efficient. So before proceeding on to, I have few case studies on some interesting applications. Basically, students can easily understand. I have 3 case studies today for you. Before getting into case studies, I just want to hear from the students how are they enjoying the session today. How any more doubts or something like that in the chat or something.
It was good. They're replying the thumbs ups.
Okay, I couldn't see, so
I had to.
it's okay.
Guys, show us your love and tell us how is the session, how is it going on? Are you
Hope
feeling
I'm not
interested?
boring you. Hope I'm not boring you much, because even though it's like a very basic level intro, there's a lot more to discuss in future. Just a 1 hour session, I couldn't talk much in detail.
They are commenting. It's so good.
Okay. Hope everything is going fine. We can discuss a lot more in our community later on. And also you can reach me out personally as well. So let us continue. Hope my screen is still visible to you all.
That's
So
visible.
talking about the case study, uh, one, smart agriculture. Smart agriculture is something which is booming nowadays. Everybody are planting their own, taking projects like greenhouse, in-house farming, hydroponics, and many more things. Smart agriculture finds application in such scenarios, or open fields farming also it finds application. Basically, here the problem is water scarcity and inefficient irrigation methods waste resources. So basically, if let's consider an open field which is having a non-flat terrain. The entire farm is not flat. It's like hilly somewhere. I mean, it has high terrain, it has low terrain. So when you release water from its source, generally, in India, our farmers take their own path to flow the water. So when you release the flow of water from the source, it might not reach the terrain high terrain area, and that area might be poorly irrigated, which will result in the improper irrigation. So I mean, that will result in improper yielding of the crop in that particular region. So if you want to implement something smart to enable to solve this problem, you will put few water moisture sensors, few environmental sensors like air humidity sensor, temperature sensor, ultraviolet sensor, and many more things across your farm. Here on the left side of the screen, you can see a small pictorial representation of a smart farm. So here you can see a soil ingredient sensor, soil moisture sensor, air humidity sensor, temperature sensor, ultraviolet sensor, being planted across your farm. And these sensors are communicated to the internet over a using a microcontroller. And the farmer or the owner can see what is happening in the farm, and there will be a controller which can control the irrigation. Let's say that the problem which I was talking, improper irrigation. Let's say that now you have a drip irrigation in your smart agriculture system. Let's say that one section of your farm is not receiving water properly. You will get an intimation, and the controller also get the intimation through the sensor that this section is not properly irrigated, even the water has been supplied for 30 minutes or 1 hour. So the controller now focuses on sending more water to that site, and same time a farmer or the owner can get intimated that this area is not getting proper water, to check whether the pipelines are damaged or anything wrong is happening in that section. That ensures that the farm is properly irrigated. And not just this irrigation thing, basically the soil ingredient sensor, air humidity sensor, temperature sensor, and the UV sensor help us understand how much how nutritious the soil is, how much humidity is maintained. Because when we basically implement smart agriculture, we the farmers generally do farming of exotic plants like broccoli, geranium, the dragon fruits, or which are not of Indian origin. Basically, there what happens is those kind of crops need additional care and very precise nutrition and very precise environment around them. So these environmental sensors will help us understand what is lacking. Let's say that more UV light is being received. You will increase the thickness of your greenhouse, or you will reduce if the UV light is not enough. You will reduce the thickness or reduce the sheet over your greenhouse. And then air humidity, temperature sensor. If temperature and the humidity are more in your greenhouse, what you will do? You will increase the airflow to reduce the temperature and humidity in the region. And the same thing, soil ingredient sensor. What it will do? It will help you understand the basic minerals are there in the soil or not. Whether you have to replenish using appropriate fertilizers like sodium, magnesium, potassium, and many more minerals are required for the soil to give proper yield from the crop. So this soil ingredient sensors help us uh, get the proper information about our soil, and accordingly the farmer can take action. And what will be the result? Obviously when you're implementing something smart, obviously you will expect a return. You either see savings in your water, or increase in your crop production. With all these measures, this is how smart agriculture is helping farmers in getting better yields. And all these things are developed using embedded system. Everywhere each sensor is an embedded system, a controller is an embedded system. So here it's a very good example of implementation of embedded. Second case study I would like to talk is about wearable health devices. Wearable health devices, a very most common application is smartwatch. So smartwatches now, each and every guy almost is wearing smartwatch. Smartwatch, here you can see uh, on the back side of the smartwatch, you can see two lights. So in some cases, it will be red light. Some cases, it will be green light, glowing always, shooting some light onto your hand. What it actually does. So it actually measures the heart rate, ECG, saturate oxygen levels. And from your smartwatch, basically you use smartwatch not just to see what time it is. So you will measure your heart rate, you will measure how your oxygen levels are there, what is your stress levels. Based on your heart movement, it will tell you how stressed you are. And even most advanced wearable health devices like Apple watches and Samsung watches, there is a history that they have predicted heart attacks of the customers who are wearing it. So all that is because that red light or the green light which is glowing on the back side of the device, it's not some random light. It's some infrared light that is being shot onto your skin. When that uh, you know light reflects back, there is a transmitter and a receiver. On the transmitter side, basically this light is being emitted. On the receiver side, it will observe the reflections coming back from your body. This light can penetrate through your screens into the blood vessels and observe the speed of the blood. And through that, it will predict you the heart rate, oxygen level, and many more things. And based on that, applying machine learning and deep learning algorithms over the data that it has got, it can predict the heart attack. That's how Apple Watches are predicting. It's not just one or two. Numerous cases have been uh, prevailed on the internet that Apple Watch has predicted my heart attack in 1 hour before or 2 hours before. It was very helpful for the candidate to reach the hospital before the actual heart attack was coming in, something like that. And stress levels and many other things. All these things are being given by this wearable health device. So what's the problem? Need for continuous real-time health monitoring outside clinical settings is very much needed in nowadays, fast-paced life. So an embedded system is giving you a solution by giving you heart rate, ECG, oxygen saturation levels, and and many other insights about your body through a small gadget. And result, what it is, making you do after seeing these numbers. So if you feel that your heartbeat is more than normal, you basically try to meditate or take a rest from what you're trying to do then. And sometimes if your heart rate is very abnormal, most of the time you will, do some diagnosis with a doctor and, get it treated properly. So this is another important case study and most important, most common application of embedded systems that you can see in your daily life. And third case study for today I will talk is like automotive ECUs. So I have talked a lot about these ECUs in the beginning of the session, like anti-lock braking systems, control of the fuel that is going in, many subroutines of the engines. So the similar things, um, like automation, advanced driver assistance systems, ADAS. Different levels of ADAS have come into the picture. Better efficiency, based on the throttle input, from the user and based on the performance modes selected by the user. Nowadays, even in the bikes and cars, you see eco mode, normal mode, and super fast mode, or some performance mode. Each company calls it different with its own branding, but like economy mode and normal mode, and then the performance mode. And based on the mode selected and based on the throttle input and the driving dynamics, the fuel economy is optimized and the engine performance is also optimized. All because there is a brain, processing all these inputs. And comes about the safety. Now, automatic braking system has come, automatic collision avoidance systems have come into the picture in very high-end cars, something around 25 lakhs and above. Uh, you can see these systems inbuilt and they are mandatory in those cars. Like let's say in Volvo lorry, heavy vehicles, this safety features like automatic braking system, it will automatically brake if there is a obstacle all of a sudden. It has saved many lives abroad. Basically, these high-end heavy vehicles are not found yet in India. They are, the same features are now being implemented in our Tata, Ashok Leyland, and Bharat Benz as well. But in foreign Scania and many high-end heavy vehicles do have this important safety feature like automatic braking system. Let's say you are passing through a village, all of a sudden a child runs and a heavy vehicle coming at 80 kilometers per hour, if it hits, it's going to be fatal. So this automatic safety systems kick in then if it sees an obstacle and it automatically applies brake and it ensures that the damage is mitigated properly. So similarly, there are many other applications of embedded systems in the automotive segment. So another thing I forgot to mention, airbags. As airbags are deployed when a collision is detected. How a collision is detected? There is something called motion reference unit inside the car, which detects the motions, roll, pitch, and yaw of the car. If it sees that there is an abnormal acceleration, basically when your car is going smoothly, it will have a constant acceleration. Let's say that you hit it sometime, the acceleration suddenly stops. There will be a strong deacceleration, which indicates collision or something abnormal. So if the deacceleration is beyond the thresholds, airbags are deployed and it saves your life. And mostly, like, airbags have saved many fatal accidents. They just come out walking just because airbags are there. Imagine that the airbags are not there. It would be difficult. Or let's say that the airbags are not deployed. It would be, a fatal accident. So that's it for the case studies. Let's talk about the market size and how the market trends are there in this embedded. So the current global market is around 95 billion US dollars, pretty huge market. And by 2030, it is expected that it will reach 140 US billion dollars. So you see the potential, how much, it's like almost 50% growth in the matter of 5 to 6 years. So you see the impeccable potential for the careers in embedded systems. As long as the applications keep on increasing, the requirement of the workforce behind that technology is also increasing rapidly. And yeah, as mentioned, like 47% growth rate is there over the next 7 years, 6 years in this particular market. And one more interesting thing is that, like, now most of the you know uh, young students are focusing basically in India. In foreign, it is very diverse. It's not more concentrated towards IT, and it's not more concentrated toward core. In foreign, basically the education is very diversified. The equal number of students will be studying IT, and equal number of students will be studying core, because they learn in the way that they are supposed to be. So that's how they never lose interest like us, and they will not skip the core technologies. So in India, if you see the trend, I guess you also will definitely feel the relevance to it. Most of the students who are now taking up bachelor's in technology, they always tend to go into the CS departments like IT or AIML, data science, or anything related to software. Uh, if you see the number of students enrolling into the core technologies like electronics, electrical, mechanical, aeronautical, automobile department is completely extinct nowadays, but I don't know why. The market is always constant. It's just the societal pressure that was created, and it was completely out of many colleges. Even many government institutes have very poor intake in core technology. Seeing this trend, there will be a huge shortage of skilled professionals in this market in the future. Down the line, next 10 years, it is expected that now there is a 30% shortage right now in the market for the young professionals in this embedded systems and core technology market. Down the line, we expect it to be more than 50%. 50% of the positions left will be left you know, unoccupied in the industry, which will be very serious. It will slow down the progress in this market. So many companies like Qualcomm, uh, Microchip, Atmel, and many companies are looking for young professionals like us to get into this market. They bring innovation, because young workforce is very much important in every industry, because they bring the revolution. So that is going to be lacking in the future. So if you guys can focus on this right now, your career will be very solid, very stable in the future. Though you might not be, making 10-digit salary or 8-digit salary, but you will be happy making 6 to 7 digits of salary constantly for the rest of your life. And compared to IT, these core industries have very good work-life balance, very constant job security it has. It's almost like getting a government job. Getting a core job in a core industry is almost like getting a government job nowadays. As I was already talking about, talent shortage crisis, growing demand. Industries are already needing, young people like us to get into the industry, bring what we have learned in our academics, implement it. All the technology now what we are seeing was, brought by young academicians back then. Now it is industrialized and now we are getting them as a product. What about the future 10 years later? People like has to step in and take the latest advancements in academics to the industry. There's always a difference between what you learn and what is there in the market. So let's take a small example of any product. Let's take your smartwatch. The smartwatch technology, in terms of academics, it is developed like 10 to 15 years back. But now you are seeing it in the industry very popularly. I mean, in the commercial market, very popularly, because after 10, 15 years, something got invented, it is now commercialized. So what about the things which are being invented right now? uh, Many, quantum computing, many other, core techs are being invented right now. Who are going to make it commercialized? It should be people like us who are young right now can take all these things into the industry. Talking about the skill gaps, graduates are lacking serious skill gap. uh, you know, Graduates are not focusing on acquiring proper skills. It's basically because of, what the colleges or institutes where they're getting trained are not being, teaching the industry required skills to the graduates. That's how the skill gap is increasing year on year. And the future need, with data says that 1 million professionals are needed in this embedded system industry by 2030. Career opportunities in embedded systems are ample, and I would say that the diversity is plethora. Plethora of industries are hiring for embedded system engineers. High demand roles. If you want me to talk about the roles in specific, embedded software engineers, firmware developers, system architects in IoT, robotics programmers, and many other high demand roles are available. Talking about the industries, automotive, aerospace, healthcare, consumer electronics, defense, you know, uh, many more. Beyond these industries, there are many more industries: steel industry, paper industry. Every industry is embedded in. Compensations, as I told you, competitive salaries are there. The more skilled you are, the more the payment you get. Now, anywhere if you start off, you can start off from 6 to 7 lakhs per annum. Sometimes, if you cannot get a good, MNC in this kind of roles, you might start with 4 LP, but like the growth you will have will be exponential because of the skill gap and the, higher demand that the industry is facing right now. Skill requirements, basically as a student, if you want to land on a job in embedded systems, basically you have to, master. You can be jack of all these things, need not master any of these things what you're seeing right now on the screen. I would encourage you to take a screenshot, or maybe this presentation might be available for you for your future reference later. Then you can take the reference. So these are few skills that are very important for any student to have an idea of. Programming controller system in embedded languages. Knowing the basics of RTOS, microcontroller programming, interfacing multiple sensors, on understand how the sensors are working. Talking about tools, oscilloscope, multimeters, logic analyzers, PCB designing tools like KiCad, Eagle. All these are freeware tools. These are very much important. If you are an embedded software engineer, it doesn't mean that you need not know how to use an oscilloscope. It is very much important for you to understand how to use this oscilloscope, to debug your circuit. On the right, you can see a picture of a guy debugging an embedded system using an oscilloscope. He's understanding, how the waveforms are being generated, whether the waveform being generated at that particular test point is matching his periodical reference or not. And soft skills, problem solving, analytical thinking, basic documentation, teamwork. These are always expected by any company. You know, let it be an IT company or an core industry. All these are just basic skills that you need to develop, to solve problems, to work along with team. So learning pathway. So based on my experience, if you're a beginner into this embedded systems, you can get started with Arduino ecosystem or the Pi ecosystem. You can use Blockly programming interface. Blockly programming is like block programming thing. You need not write the codes. There will be certain set of code blocks available. You just need to interloop them to get the actual function. And basic sensor interfacing, ultrasonic sensor or the IR sensor, motion sensors, and many basic sensors are there. So take any board from the Arduino family, like let's say Uno, Mega, or Nano, or take a Pi 4 or 5, and interface it with basic sensors, and understand how these systems are working in an eagle perspective, and then move on to talking about the intermediate level of skills. Arduino, Raspberry are very good to start with the embedded systems. But when you want to get into serious embedded development, you need to understand how to use this ESP32, STM32. They are far more advanced than Arduino, and the architecture is ready for the industry. STM32 is used across many embedded systems. Many of your smartwatches have STM-based microcontrollers, and ESP32. Many of your IoT devices are based on ESP32. ESP32 is an excellent, microcontroller system. It can, you can program over RTOS. You can program, you can use it on robots. You can use it on IoT-based devices and many things. And then you need to understand how these communication protocols work in detail, like SPA, I2C. Earlier, I told you you have to master few communication protocols to make you stand out in a crowd of embedded system engineers. So there will be something called timers. I would encourage you to take a screenshot of this slide also. Please highlight very important things in embedded systems for an aspirant to master. And if you want to go into the advanced level, you need to understand how bare metal programming works, because basically most of the work as an freelancer or as a student, we basically use libraries from community. I hope you understand how libraries are working. Someone develops a hard part of the code, you basically use that library, fetch functions, use functions of that library to fetch important values directly. You need not do the hard computation by yourself. But when you're moving on the advanced level, you have to write everything by yourself. There should be no libraries used. Bare metal programming. Even if you want to do an addition subtraction, you should not use any function. You have to do everything bare. You have to write it on yourself. And then RTOS, real-time operating system, embedded Linux, ARM Cortex M series, microcontrollers and processors. These are few things which are very much advanced. Once you tick off the beginner and intermediate cycles, you need to learn about this bare metal programming, RTOS. Even though you're a student, it is very much important for you to understand how these things basically work, and you have to at least work on basic projects over this bare metal programming. Even you can do bare metal programming on your Arduino board with an ultrasonic sensor. You need not use any function. You just need to write everything by yourself. So there you can try out this bare metal programming, real-time operating system. Over Arduino, basically RTOS don't work, but over STM32 and ASP32, you can implement some RTOS. Free RTOS is there, Zephyr RTOS is there, Embed OS is there, many more are there. You can implement, connect 4 or 5 sensors to the same microcontroller, implement RTOS, get the data, all at the same time. Embedded Linux, you can embedded Linux to give you an application of embedded Linux. Nowadays, you see our vending machines, or ticket machines on the metro stations everywhere. You see some screen, right? It's not basically a computer with full-fledged OS. It is something called embedded Linux. Embedded Linux, enables the user to interact to an embedded system properly. And then ARM Cortex M is the ARM Cortex M is an advanced microcontroller platform or the microprocessor platform basically used in the embedded ecosystem. ARM Cortex M series are basically used on ECUs of automobiles and vending machines, as I mentioned before. These are few applications of ARM Cortex M series hardware. Let's talk about how a small student success story. Let's say if you are finally a student, if you want to develop, uh, a project to read ECG over using ESP32, you learn how ECG sensor works. You learn how to interface it to ESP32, how you're going to communicate, and then transmit the data over Bluetooth to your application. So this is the project part. What about the recognition? You have to always document your work that is being learned by you. Either it might be a white paper or a journal or a conference, or it might be a LinkedIn blog post or something like that. Just write it genuinely and give it back to the community. And then the lesson, what you're going to learn by doing this. You will start small, build consistently, document the progress, and share your work. So that is what you're going to learn. You will learn, critical problem solving skills earlier. Then you will learn how to document it, and then you will learn how to communicate it to others. So this is what basically the industry expects. The pressure to be all round in all these aspects. He must be a problem solver. He must be a good document. He must be very good in documentation. One must be able to communicate about his work efficiently among the teams. Now, learning and doing this small kinds of projects will help you develop all these skills. So, how do you get involved in, get advanced with all these development aspects? You need to participate in hackathon, workshops, hands-on workshop. Talking about hands-on workshop, we are planning to conduct one hands-on online workshop where we will develop a small interesting thing I will discuss in the later part. So getting involved, buy some hardware, do it all by yourself. That's how you will get started, and join forums like Stack Overflow, Reddit, GitHub. Give it back. Try to understand what other basically these forums are used to debug any issue that you're facing. It's basically open source. You will, if you are facing any issue, you Google it, you will get links to these platforms where other user has already faced this problem, and he will tell you how he has solved. Similarly, you have to give it back to the community. Many people will be stuck with some problems. They will be opening few questions. You try to read them. If you have gone through the same problem, you will write it back to them that this is how I solved. You will get it. So, like, this will increase your interaction within the community. It will build an portfolio for you. Talking about proper certification, if you want to get into proper embedded systems, certifications always add value to your candidature. So if you want to do something as a beginner, if you want to understand more in detail how embedded systems work, you can find many courses on Coursera. uh, Introduction to embedded systems or C platform, many things are there on Coursera. If you want to go a little intermediate, on Udemy, you can search this course called Mastering STM32 with HIF. It's a very comprehensive course on, it will help you understand how this STM architecture works, and high-level assembly language is used to program it. And then there are many advanced courses also from NPTEL, MIT, on embedded systems designs. This embedded system design courses will help you design the entire system by yourself, right from the sensor actuator to the microcontroller, the firmware, and everything. It will help you learn in detail. Industry collaboration. So it's very important for students like you to gain, industry grade skills directly from the industry, not from workshops or something like that. So it is very important for you to join internships, work with startups, work with any MNC to solve their problems. You might not solve, but you understand how the problems are being faced and how generally the problems are mitigated or solved, or how a product is developed using internships. Co-innovation labs like joint research units like Teamworks or T-Hub, or even every college has their own innovation hubs. Join them or approach your professors to take part in their research work, because research work is always interesting and it gives you a lot of scope to learn a lot of things. And then the sponsored projects, basically industry funds academic institutes to solve their problems. So you can take part in those sponsored projects to your college innovation cell, or your professors are also handling must be handling many consultancy projects. So you can get in touch with them, take part in that sponsored project. And mentorship programs. Basically, many of industry leaders personally, have interest in mentoring students in their projects or in their career. So you can get that kind of mentorship from the industry professionals to get the to be industry ready. So how to start projects? Simple, 4 point slide. I told you, multiple times in the earlier projects. Earlier sites, choose a hardware, choose Arduino or ESP32, add few sensors, do simple tasks like LED blinking, sensor reading, displaying data, or serial monitor or something, document it, share. Like that, you change the hardware, you change the sensors, you try multiple things, try making applications. You will you will start becoming a pro in embedded. So as I mentioned about our 3-day workshop earlier, you know, we'll be making a smart tracker like Geo Tag or Apple Air Tag. Basically, this is a very tiny embedded system which can tell its location when you have lost it. When your phone loses connection with this tracker, it it tells you the current location on your mobile phone, just because it has a GPS, it has a small powerhouse in it, small embedded system. It has a microcontroller, GPS, a small speaker. It also beeps. When you send an alert from your phone, it can beep. So in our workshop, you will be making one on your own. There we'll be teaching you how to select the hardware components and why are you selecting this particular hardware components, programming them, and making a PCB. And also one interesting thing is that we will also teach you to make a case all by yourself. So this is a very interesting workshop that we will be personally handling through Nodetronics technology. To the attendees right now, I would always encourage you to take up this workshop. Many more details about this workshop will be shared to you after this webinar, and you can take a closer look about it. So that comes to an end right now for our discussion today. It's been almost like 40-50 minutes of comprehensive discussion. So I would like to answer a few questions on things discussed today. So if any one of you have some questions, I'm open to answer.
Yes, so the question has been posted in the chat box.
Yeah. Let me check. So many questions about Galaxy Ring. I can see 2 questions posted about Galaxy Ring. Praneet Kopula, how Galaxy Ring works. So Galaxy Ring, it's again a smart wearable, I guess. It, it is possible because of the advancement in the manufacturing technologies of the embedded system. So earlier, a micro, like I mentioned about 100 nanometer process, 200 nanometer process in development of microcontroller system. So the same thing, since due to the advancement of this, now the microcontrollers are being developed with 3 nanometer, 4 nanometer, 5 nanometer process, which is significantly reducing the footprint of each component. The sensor size component, the microcontroller component has reduced its footprint. So they are able to, integrate all these individual discrete components in a such small form factor like a ring. Earlier, a couple of years back, the smartwatches have been commercialized. Now, the same technology is further made smaller and made, in very small size, such that it can fit into a small ring. So it will work similar like your, smart watch, but with a different form factor. And there's another question from Pranit again. And can we expect Galaxy Ring to have access to phone call and similar features available in a smartwatch? Obviously, Pranit, as I have mentioned about the advancements in technology, in future, definitely we can expect something like Galaxy Rings to enable us, even a tiny display and the sensor feedback on the ring to help us answer, audio calls or access your voice assistant, or even, you might not even wonder if you get a small camera embedded into your smart ring as well. It can be very much possible. And then a question from Jeevan Maurya: sensing, data collection, process, analyze, use algorithms to provide insights. I didn't understand this question. Even if you're online, can you
Jeevan is saying that answering his question, Pranit question.
Yeah.
Okay. Sorry. Okay, fine. Yeah, good that you're already contributing back to the communication. At least is also interactive. Yeah. Any more questions?
Yeah.
There are around 20 people in the
Students, you can drop
call
your
group.
questions in the chat box.
Okay, then I think we will share the link of our community, WhatsApp community, to the students. They can join the community and they can, keep updated about, latest tech, and they can always talk to me directly over that community if they have any doubts in their projects, or if they want to, get more detail about it.
Yeah, we also shared the registration
Cool.
form for Slate Valley, and also thank you so much for joining us today. I think so there
Yeah.
are no more questions from the students.
Yeah.
Any more questions?
Yes.
I think there are no questions today. No. Yeah. No questions. Thank you so much, Team Notrosonic Technologies, for joining us. Yeah,
Yes.
this previous classes will be available soon. The recordings will be start posting, and also we'll share this recording to the team. Yeah, thank you so much, Ashwin, for joining. It was an inspiring session, and the students enjoyed it a lot for real-time cases and how smartwatches work and how the ring works to scan and how the background, everything works. It was just so good. Yeah, thank you everyone for joining us for today. And we successfully completed our day 22 of LearnX 30 by Slate Valley and first day of the Nodetronics.
Yes. So Amulya,
Nodetronics first day successfully have been completed.
yes.
Yeah.
Yeah. Thank you, Amulya. Thank you for hosting this. So
Yeah, thank you so
and
much.
yeah, and that's a wrap for day one of our 10 days deep tech web and the hardware webinar. Yeah, thank you everyone for joining us tonight, especially all the students from the Slate Valley and all the students who joined through Nodetronics. Thank you very much. We hope you liked the webinar. You liked how we are going in the hands-on way. So today's session on embedded system was just the beginning. Over the coming days, we will explore the exciting
Topics to
hardware
go.
and intelligence. Yeah, and including how AI is being embedded into the real world devices. So apart from that, I see most of the people from Slate Valley are CS students who are
Yeah.
interested into computer science. So we would join our webinar from core industry, where you will be learning how this. If you see NVIDIA is there, NVIDIA is the main brain for all these AI things to run. So it's totally on chip designing. So come join us, learn how things are work, and now if you see even the smartphones, even the smart devices, even the smart fans, all these things are run. You see in the industry that coming on totally automation. So there you definitely need robotics. So CS and hardware should go in line. So if you know a little bit of core technologies also, it will help you guys. So if you found tonight valuable, we'd love to hear from you. Please share your key takeaways on LinkedIn and Instagram, and please tag both Nodetronics and Slate Valley. Let's build this community together and inspire others to join the movement.
Thank you so much,
Thank you,
everyone.
everyone.
Please share your takeaways